A superconductor, when it is flowing current inside the superconductor, forms around a magnetic field, just like a wire, when it's flowing current, forms around a magnetic field. Except this magnetic field isn't formed by electrons, it's formed by electron pairs or light. So the field it produces is not a positive field or negative field, it's a zero field, or a null field. It has no north or south pole. So the field it produces repulses north poles and it repulses the south poles. It's a null field. So as the current's going into it, or the amperage, literally the field gets larger and larger and larger and larger and larger. But it's a null field. And so it repulses all external magnetic fields. So whether you have a north pole or a south pole, or you have voltage potential or whatever you have, it will not penetrate the sample. It won't get in the sample. It hits it and is deflected around it. If you get a high enough field, it actually feeds into the superconductor. It eats the field. If you get a high enough field, it actually pulls that energy into the superconductor and flows more light from the field. So this isn't at all like electricity. Electricity resists the field. This, if you put a field to it, it eats the field. Wow. This is really strange. So how do you get the current out of a superconductor? You have to hook the wire up to the superconductor, and then you have to resonance frequency tune the vibrating frequency of the wire to match the vibrating frequency of the superconductor, and then apply a voltage. And out come the electron pairs, and they become electrons, and now they're in the wire going on down the road. But the neat thing about this is you can put electricity in this in Seattle and run the superconductor all the way to New York City, and you put the energy on in Seattle, and you can wait for 2 months and go to New York City and take it out, and it's all there. It's a quantum phenomenon that runs forever and ever and ever. You can actually approach a superconductor with a magnetic field, and it starts superconducting in response to the field. It takes the magnetic field into the superconductor, has electron pairs, and flows light in response to the field. Well, literally the Earth's magnetic field is a tremendous magnetic field for a superconductor. 0.56 gauss, which, gosh, that's a long ways from 2 times 10 to the minus 15th ergs. Right? That's a monster field. So literally it begins superconducting in response to the Earth's magnetic field. And it's flowing so much current inside of it that it levitates on the Earth's magnetic field. It cannot be weighed. It won't drop down because the Earth's magnetic field goes around it and holds it in the field. So it really floats. So in 1988, we filed U.S. and worldwide patents on ORMES. In March of 88, ORMES, and that was a refiling, ORMES, orbitally rearranged monatomic elements, and S-ORMES, the mini-atom system of superconducting ORMES. So we had all these patents on ORMES, all these elements, and we had another series of patents on S-ORMES, the mini-atom system of resonance-coupled atoms. And when you understand that a superconductor will not let any magnetic field in the sample, it reflects all light, what color does it have to be? White. All light's reflected, so it has to be white, or invisible. So anyway, we got this filed in March of 88, and I didn't realize that any patent on superconductivity requires approval of the Department of Defense. They forgot to tell me that part. Anyway, we go rolling along nice and comfortable. You got a year's grace here from the U.S. Patent Office that if you file your patent worldwide within a year, everything's going to be rosy. So come 3 weeks before the end of our year, we notify them we're going to file our worldwide patent. Well, before they answered, somebody went back and reread the patent. They realized it was superconductivity. Nobody picked up on this. I said it has hoofs, it has horns, it goes moo, it gives milk, and it has baby calves. But I never call it a cow. So anyway, when they went back and read it, they said, uh-oh, off to the Department of Defense it goes. Department of Defense comes back and says, you cannot file this worldwide. It's strategic importance to this country. And we said, wait a minute. By law, I have to be given a 6-month appeal period. You only got 3 weeks. By this time, Palms and Fleischmann had filed all their information on cold fusion, which if you know this, you now know what cold fusion is. I said, no. We've got to have this date. So the patent office says, okay, go ahead and file it worldwide. We'll override the Department of Defense. so in March of '88, we filed U.S. and worldwide patents worldwide in every country but China and the Soviet Union. Well, needless to say, my name was mud at the Department of Defense. They said, well, if we can't prevent him from filing this patent, we're going to learn everything he knows. And so I get this phone call from this man who says, Dave, I want to invest in your technology. I said, how do you know anything about my technology? Well, he says, well, I know you're doing this, now you're doing this. And he's telling me things specifically out of my patent. And nobody's supposed to ever seen this patent. You know, the Patent Review Board's supposed to have seen it. And the Department of Defense Review Board's supposed to have seen it. But nobody in the military should know about this. And yet this man's quoting me verbatim from my patent. So I hired a private investigator to check him out, find out who he is. Come to find out, he flies out of Langley Air Force Base. And what happened is when the military went to Congress to get approval of funds for Star Wars, Congress turned them down. And so what they did is they took a bunch of covert money and they put it over in Swiss bank accounts, and this man takes that money and goes to companies who have technologies that serve the Department of Defense interest, and he invests money in them. And then you have a partner at the Department of Defense. And so I said, no, I don't think we need your help. And he said, Dave, you will never prove this without us. You will wait 2-3 years before you can ever get your material on the neutron deflection studies, which are the absolute proof of superconductivity. A superconductor repulses all external magnetic fields, including the spin charge of a neutron. A neutron has no polarity, but it does have a spin charge. And a superconductor is the only thing that literally will deflect the spin charge of a neutron. So anything that's superconducting cannot be seen with neutron activation. I said, well, I already know that. I don't need that analysis. Anyway, he was back 2 or 3 times, and after that, he just dropped it and left. He never came back. We just continued along our merry way doing our research.